Okay, so we've got a circuit diagram here with a voltage source and two resistors in series, and what we want to find is the value of this resistor that will cause a 2 volt peak-to-peak voltage across this 1 kilo ohm resistor when we apply 5 volts RMS AC voltage to this little circuit. So I'm going to go ahead and use all max values to figure this out, but you could use RMS values too if you wanted to. So for the source we have an RMS value of 5 volts, and we know that RMS values equal the max divided by root 2. So Vmax applied to this circuit is equal to 5 root 2. And then Vmax for the 1 kilo ohm resistor is going to be half the peak-to-peak voltage. So that Vmax is just going to be 1 volt for 1 kilo ohm. So Vmax across this other resistor has to be the voltage, the maximum voltage applied to the circuit minus the maximum voltage across this first resistor. So that's just going to be Vmax for our unknown R is going to equal 5 root 2 minus 1. So if we do a little plus minus here, this will be 5 root 2 minus 1. But we still don't know the resistance value there. So we're going to use current to find that. If there's a current flowing through here, it's going to reach a max at the same time this source is reaching a max. So we can find the max using the maximum voltage across this 1 kilo ohm resistor since we know its resistance value. So our maximum current is just going to equal 1 volt divided by 1 kilo ohm from that first resistor, which equals 1 milliamp. So now we have voltage and current through this resistor, so we can find the value. R is just going to equal Vmax over Imax, which is 5 root 2 minus 1 volts over 1 milliamp, which equals 5 root 2 minus 1 kilo ohms. And if I go find my calculator real fast, then that resistance value is 6.07 kilo ohms. So if we put a 6.07 or something near that kilo ohm resistor in here, and we apply 5 volts RMS to this circuit with a 1 kilo ohm resistor, then there'll be a 2 volt peak to peak across this resistor.